Okay, so today we're going to be kind of introducing the idea of scientific notation. Scientific notation is basically another way of expressing numbers that allows us to express very large numbers or very small numbers in a short amount of space. So instead of having to write like a bunch of different zeros and stuff like that. Okay, now as you guys can see, these numbers, we all have some number times some 10 to some exponent. Basically, that 10 is telling me how many spots I need to move my decimal and in which direction. Okay, so if it's a positive exponent, it's going to be a big number, so it's going to be, a very big number. If it is a negative exponent, like this right here, that means it's a very small number, which means it's going to be a decimal. Okay, so since this is a positive exponent, that tells me it's going to be a big number. And since it's positive, that means I'm going to move my decimal in the way that would make it a big number, which would be to the right. And the number of spots I move the decimal is just the number of spots that I have for the exponent. The exponent is 3. So that means I'm going to move my decimal 3 spots. Sorry, I'm adjusting the zoom here so you can see the numbers better. But since that exponent is 3, I'm going to move my decimal 3 spots to the right to make it a bigger number. So if I move it 3 spots to the right, so it'd be like 2.4000000 whatever, right? If I move it 3 spots, it's going to be 1, 2, 3. My new number is going to be 2,400. Okay? That's that all brought out and bigger. Okay, again, this is a positive exponent, and this exponent is 2, so I'd move my decimal 2 spots to the right to make it a big number, and be 674. Okay, and again, positive number means it's going to be big, so it wants me to move it 8 spots, so it'd be 1, and then I'd have another 8 spots here, so it'd be 1, 2, 3, 4, 5, 6, 7, 8. There would be my new number, 100 million. Okay? Now let's try looking at the negative exponent. Negative exponent means the number is going to be getting smaller, right? So that means I'd be moving the decimal to the left, making it a smaller number. Here I'm moving the decimal to the left 6 spots, so it's going to be getting smaller, so it's going to be 0.0000012. So again, it was right here to begin with, so I moved it to the left 6 spots, so 1, 2, 3, 4, 5, 6. Okay? And that's basically all you do here to convert. So like this is -3, so that means I'd be moving it to the left 3 spots, so it'd be 0.0069 would be that answer. Okay, then to convert to scientific notation, in order to be scientific notation, you'll notice all these numbers are greater than or equal to 1, but less than 10. Because if it was either of those, if it was less than 1 or greater than 10, it would be, I'd have to move it over to add to the 10 spot over here to get my actual number. So I want to get these numbers so that it has a number in front that is greater than or equal to 1 and less than 10. So right here, the decimal starts right here. I want to move it so that it is 1, 2, 3 spots over so that I get a 1 in front. So I'm going to have 1 times something, and it's always going to be times 10, but what it's going to be times the exponent on the 10 is going to be based on the number of times you moved it over. So I moved it over 1, 2, 3 spots, and this is a big number, not a decimal, so it is a positive 3. And right here, it moved over 1, 2, so it would be 3 times 10 to the second. Okay, but this is a decimal, so a small number. And again, I want the number in front to be greater than or equal to 1 and less than 10, so I'm going to have to move it over 1, 2, 3, 4 to get 2.1. So I get 2.1, but then I would times it by 10, and since I moved it over 4 spots, b to the 4th power, but since this is a small number, and I want it to become a small number when I'm done with it, that's going to be a -4, right? Because it's a small number. I don't want it to become a big number when I multiply back through. I want it to be a small number. Remember, negative exponents are fractions, so this is basically like taking the fraction of 1 over 10 to the 4th and dividing 2.1 by 1 over 10 to the 4th power. Okay, let's look at another example. Let's do this one right here. So this is 18 million, right? So the decimal starts right here. I want to get it so the number in front is between 1 and 10, so it's going to become 1.8. So I'm going to have to move the decimal over 1, 2, 3, 4, 5, 6, 7 spots. So it'll be 1.8 times 10 to the big number, positive 7 power. Okay, let's do another small number. Let's look over here at this one, 0.128. Again, I want to move the decimal so that it is, the number in front is between 1 and 10. So this is below 1, so I want to move it over so that I get 1.28. That's more than 1, less than 10. But since I did that, I'm going to have to times it by 10, and since I moved it over one spot, it'd be the 1 power, but it's a small number, right? So it'd be a negative 1. And that's basically all you're doing there for scientific notation.